So we just went ahead to rewind, and we're gonna take a look at during the daytime. And Faisal, just give me a shout out if you can hear me now. So I'm gonna go back a couple hours to daytime, and now we have the moon out, but it looks like Jupiter has disappeared. So we're just going to kind of scroll in, zoom in a little bit, and see, oh, look, there's Jupiter. All right, so it can be seen during the day. It's kind of tricky. So it helps to have the moon as a marker in the sky. So once a month, the moon is going to kind of pass by where Jupiter is in the sky, and then we'll be able to see that. So that's kind of a fun thing. Again, that's going to happen on the 22nd. So if you look out, find the moon during the day later in this week on October 22nd, you can look and see if you can find Jupiter in the sky near it. So that's a fun thing, a little bit of a challenge. For an extra challenge, another thing to try that really you can only do every now and then. So the Jupiter in the sky thing, that happens about once a month. But another kind of tricky thing is trying to find Mars during the day. And I don't even know if this is possible. You should at least be able to see it in binoculars, if not with the naked eye. So if we wait a little bit later in our month, so we're going to fast forward past the 22nd. I think we're going to the 29th. So yeah, it's kind of between the 28th and the 29th that the moon is going to be relatively close to Mars in the sky, as seen from Earth. So in theory, because Mars is actually appearing brighter in our sky than Jupiter is, usually Jupiter is the next brightest object after Sun, Moon, and Venus. But for now, it's actually Sun, Moon, Venus, Mars, Jupiter. So that's going to be happening. And yes, and there's a shout out, there's going to be some, so Faisal said he is able to see Jupiter from Brooklyn Bridge Park, it looks like, which is one of the places that I actually saw it during the day as well. I think it was a different day, but I have seen it. Mars, I haven't, but I'm going to try this. The really tricky part with Mars, though, is that if you're going for daytime, we have this issue of the sun setting early this time of year. So just as the sun is setting, Mars is rising. So it's going to be hard to catch it during the daytime because it's going to be so close to the horizon. So just harder to pick out. But like I said, it's a challenge. So Jupiter, that's a first challenge. Find it in binoculars and then see if you can see it without your binoculars with just your eye. And if that goes well, then a few days later, look for Mars and see if you can see that before the sun actually sets. So that's my Uber challenge for you this week. So those are some moons and a Mars. And one other thing I just wanted to point out, if we go ahead and look at, we'll let this get a little bit later in the evening on the 29th. And of course, shout out to the blue moon coming up on Halloween, which is also kind of why we have the theme that we have for this month. So there's going to be a blue moon. Very exciting. It won't actually look blue. It's just, like, you can look it up. I'll probably put something on the AAA side about that. So I want you to notice, this is kind of like a view that I might have in my telescope. Yeah, like so, ish. Right? So we start to see a lot of craters and a lot of detail. I want you to notice this crater kind of off to the side here. I believe this one is Aristarchus. So big, bright spot, like stuff coming off of it. So that crater is about 40 kilometers wide, and it's just a little bit smaller than the first moon that we're going to be looking at tonight when we get to open space. All right, so that's a 40-kilometer crater on the moon, which is about 240,000 miles away. Okay, so you're not really going to see that with the naked eye. Definitely need binoculars or some magnification to see that. So just a little context. All right, so that's our night sky and the daytime sky. Some good challenges there. Let's pop over to open space and start exploring some other moons. So we'll leave our moon. There's the Earth. And again, with open space, you can basically, fly around the universe in 3D. So we just load a bunch of data in here, and I'm going to fake some of it tonight, and I'll try to let you know what's fake. But here we have the Earth and its orbits, and we're going to be going towards the outer part of the outer solar system because that's where the moons are. There aren't very many moons in the inner solar system. So first stop, as we head out, we're going to head out to everybody's favorite dwarf planet. That's right, kids. Going to Pluto. Not a moon, not a planet, but it's a dwarf planet, and it has moons. 5 of them. Go Pluto. All right. So there we have Pluto, and you can see its largest moon, Charon, and they kind of orbit around a common center of mass. So you can even see kind of Pluto's little orbit around that common center of mass. It's called the barycenter of the system. If we kind of play time a little bit, you can see them kind of orbiting around each other. Oh, there they go. And then the outer moons, orbiting a little bit more slowly. Right. So we have Pluto and Charon, and then the larger moons are Hydra and Styx. Hydra and Nix, and then Styx and Kerberos are just like really small. So Hydra is actually the second largest moon, but it's much, much smaller. Hydra and Nix are about the same size. But Hydra is the furthest one out, so it's way out here. And of course, it's very, very far from our solar system. And I'll go ahead and just target that one. So it's far from our solar system. We've never been very close to it. And so we don't have very good images of it. So I brought other pictures tonight. All right, so here we are about, I forgot to convert to kilometers. Yeah, so this is this is maybe about the distance that the New Horizons was, actually a little bit further than this, as far New Horizons was when it caught an image of Hydra. So our best images were taken from about 144,000 miles, and Hydra along its longest part is about 50 kilometers across. So I know I'm mixing units up all over the place, but remember we were looking at that crater. That was a 40-kilometer crater, 244,000 miles away, and it's just like way too many numbers. So the point is, it was far away, and Hydra is really small. So if we zoom in here, we don't have a pretty map of it. That's okay. But again, this is the second largest moon of Pluto, and it's more dense than water, which is great. It's about twice as dense as water. And so it's probably actually got some rockiness to it, and it's relatively bright for just a little moon. So probably a lot of actual water ices. It has more of a bluish hue. If you look carefully at all the colors in it, it has more of a bluish hue in real life than the other icy moons of Pluto. So here we're just seeing kind of a ball. It's not really that spherical. It's actually kind of lumpy. So probably a bunch of space debris. And again, because it is kind of lumpy, it's not super, super round. I brought a picture. Let's see if I can find my picture. There we go. So it's a little blurry because I blew it up a bit. But yeah, so that's the moon. Kind of lumpy, and to me it doesn't really look like a moon because again it's around 5, so these are gonna be moons that are not so round. And yeah, for this one I said this one looked more like an alpaca. So this is Hydra the alpaca. So I don't think it looks really much like a seven-headed monster, but more like a cute fuzzy woolly thing. Um, so this is that's our first non-round moon that's cleverly disguised as an alpaca, we'll say. All right. So visualized here as a sphere. So assume a spherical alpaca, and that's Hydra. Right. So a lot of kind of small, lumpy collections of debris and ice in the outer solar system. So that's Hydra. All right. So if you're looking for, really this is like if you're looking for, Halloween costumes or anything, or if you want to do like a socially distanced, like very spacey, these are all socially distanced moons, all spacey kind of themes, you can dress up as Hydra and go as an alpaca. That's my suggestion. You're welcome. So next, let's head in a little further, closer to the sun. So that was like our far out moon. And we're going to visit 2 moons of Saturn. So Saturn has just a whole mess of moons, just a couple in here. One of these days we'll just like zoom around all of them because it's kind of glorious, all the moon data that we have for Saturn. And we do have some better pictures. We don't have full maps, so I can't show like full on maps of Saturn. But I do want to just jump to real time. There we go. So we have, you see a couple of the kind of teal orbits in the outer part. So we're going to be looking, actually, speaking of alpacas and sheep-like critters, we're going to be looking at shepherd moons. So some of the moons that are within the ring system of Saturn, those are some shepherd moons, and we're going to start out and work our way in. So one of the outer, kind of along the outer parts of the F ring, we have Prometheus, and then across from it is Atlas. And so I can't really tell you which one of those is which right now. So I have to actually aim at Prometheus. Okay, so that one's Prometheus. So we can see the rings of Saturn, this beautiful ring system. So it goes from D to A. So we have D, and I think this part is C, B. A has the Echi division in it, or the Echi gap, so this little gap in here, and then this very fine bit out here is the F ring. So they don't all go in order. But if we zoom in here, we can see kind of a little bit of the shape of Prometheus. Again, this isn't totally accurate, but I brought pictures for you. So you can see it is oblong. All right, so very close, just outside the ring, and it kind of like gathers bits from the ring. So it's kind of this this oblong bean shape, but more on that in a minute. Prometheus, not an alpaca, but it is fluffy. It's less dense than Hydra. So Hydra was more dense than water, but this ring and the next ring, this moon and the next moon that we're going to look at are actually less dense than water. And I think we've seen that with some of Saturn's other rings that are basically just big piles of rubble. So very, very dense, a lot of gaps and just air in them. So we saw one of the rings that was just really spongy. So this one, from the best images that we have, not as spongy. This was actually discovered in 1980. So we have some of the Cassini images of it, but it was found in 1980 when Voyager 1 went whizzing by. So also very reflective, so, probably some ices, but it's much longer than it is wide. It's like 130 kilometers long and then like only 80 kilometers at the next widest bit. So, so let's go ahead and see our pretty picture of... Yeah, not the alpaca. There we go. So there's a little bit of Prometheus. So when I saw that, I said, amoeba? But that's not as fun. So I decided to go with something a little bit cuter, and I said, cuttlefish. So you look at that. I mean, really, tell me that's not a cuttlefish. I dare you. Especially like a spotted cuttlefish, right? Because it has all those craters and stuff in there. So it has kind of like this ridge around, I guess it's middle-ish. One, it's oblong. It has this kind of ridge around it. So we think that's from picking up some of the debris from the F ring. So it's kind of shepherding, but it's kind of exchanging material and gets this extra collection around like kind of a little bit of the equatorial region there. So that's our that's our next not round moon. So we're gonna call that Prometheus the Cuttlefish, kind of cuttlefishy. And again, a lot of the other moons are not super round either. And actually, the next one has a similar feature to Prometheus, but I just have to cheat and make a small adjustment to Saturn. So some of the fun things we can do in open space is we can actually make things bigger or smaller than they really are. And I wanted to get this into just the right spot. So I had to cheat a little bit. So, all right, so ignore that. So say goodbye. Say goodbye to Prometheus. And let's see if we can pop over to our next moon here, which is Pan. So Prometheus and Atlas are kind of across from each other, or near each other, kind of very similar orbits around Saturn, actually kind of poke each other every now and then. Pan is just a little bit further in. So I think we got it. Yes. Okay. So I worked so hard to get this, and it came out just a little bit off. Okay. So so Saturn's rings are just they're not exactly centered. So I think if I move time a little bit, I could actually get this blob to be in this gap. So our next moon, so Pan, is actually within the gap of it's in the Ecky gap. And I'm wondering now if I think I may have actually done the wrong sizing. So let me just try this one more time with my Saturn and make kind of fake Saturn a little bit to get it to be a slightly different sizing. And nope. Okay, yeah, no, it's not working. That's all right. So actually Pan is out. It's out in this. Yeah, it is out. It's in that gap, in the Ecky division. So this kind of thin division here. So the largest gap in the ring system is the Cassini division. So that's what we see a lot if you look with a telescope from Earth. One of the fun things we look for is this kind of larger gap in the rings where there's more spacing in there. So we look for the Cassini division, and then on a really good night, sometimes you can see this finer gap out here. So this gap where Pan lives and collects material and distributes material, it's only about about 300 kilometers wide. Not very wide, but just kind of this narrow gap in the ring. So that's where Pan is. It's kind of like sweeping up material. So it has a feature similar to Prometheus, and that it has kind of a ridge around its equator. So I can kind of show, there's Pan. And I'm sure there are some other ideas popping into your head saying, okay, if I wanted to dress like Pan, how would I need to dress? How would I pull that off? And I know the people at the Cassini group, when they were getting these more detailed images of Pan, they said, yeah, that looks like a walnut. And I don't know, I didn't think walnut. I thought ravioli. That was the first thing that came to mind, is this is the Ravioli Moon. So it's pretty small. It's only about 36 kilometers across at the widest bit. So kind of on the on the ridge there. But again, it's collecting all this material, and it's also less dense than water, so probably a lot of like debris, a lot of rubble, so kind of rocky material, some ices, and probably very porous, similar to some of the other moons that we've seen. The other interesting thing about Pan is that in this gap in the Echi division, there are also kind of ringlets, so kind of streams of material that the moon interacts with. And so some of those it's kind of in stable orbit with, and so it's kind of like taking and exchanging material with those. And then there's another ringlet that has a slightly different orbital period, so it actually passes that in its orbit and really disturbs that. In the same way, Prometheus really disturbs the F ring, and so you get kind of like these wrinkles or waves or knots in the F ring as these other moons, as these shepherding moons go by. Other fun fact about Pan, just in case you visit, if you want to go visit a walnut or ravioli shaped moon, don't jump too high. The escape velocity from Pan is only 6 meters per second. So Pan actually wasn't discovered until 1990. So when the Voyagers went by, they apparently imaged it, but no one found it. So someone went back in the 90s, actually in 1990, and was just looking through all the images from Voyager 2 and found Pan in there. So Prometheus was big enough, it was actually discovered like when Voyager 1 went by, and then Pan wasn't found until 10 years later. So those are a couple not so round moons. So they all have some kind of shape, but not necessarily what we would generally think of a moon shape. If you want to dress up as a moon, you don't have to be like gray and round and cratery. You can also dress up as an alpaca or a cuttlefish or even a ravioli/walnut if you want. So I hope you'd enjoyed this episode of Moon-topia, round 5 for the not round things. If you have requests for future Moon-topias, feel free to let me know. You can leave it in the comments or email irene.pease@aaa.org. Again, I'm Irene Pease. You've been watching some open space visuals, stellarium visuals, and I'm here with the Amateur Astronomers Association of New York. Go ahead and check out the other things that we have going on at aaa.org, or you can follow us on the social media things at AAA DOTORG. I just want to mention we do have a new class coming up. If you want to learn more about astronomy and you don't have a telescope, you can learn all about astronomy before the telescope. So that's going to be on Wednesdays. You can find out more information about that on our website. So thanks again for joining us for Moon-topia in October. We'll be back in November for another Moon-topia. Enjoy the night skies in the meantime. Good night.